Hi guys, welcome to this set of videos. What we're doing here is we're going through sort of this idea of triangle congruence and how we can prove that triangles are congruent. Now in the last section, the last set of videos, we really were kind of introduced to this mouthful that's known as the corresponding pairs of congruent triangles are congruent, or CPCTC for short. And again, man, it was a lot of work, because what we had to do in order to use that theorem was we had to show that all three pairs of corresponding sides and all three pairs of corresponding angles in a triangle were congruent. You essentially had to prove 6 things. All three pairs of sides and all three pairs of angles were congruent. That's a lot of work. What I'm hoping is that there's a shortcut. And in fact, it turns out there are. There are several shortcuts to proving the congruence of a triangle, and we're going to get our look at our first shortcut here in this set of videos and these notes. So let's take a look at our essential question first, and then we'll dive right into these. To get us started, we want to ask the question, what does ASA, Triangle Congruence Theorem, tell you about a triangle? ASA. That is the abbreviation for this. It means side angle. Side angle. Whoa. Angle. Side angle. So the ASA, angle, side, angle, triangle congruence theorem, what does that tell us about triangles? Well, again, to sort of jump into this idea, right, several objectives, things that you'll need to know to really sort of help you do these problems. But again, keep in mind the idea, the theme we're going to see here over the next several sections is proving triangles are congruent. So I think you can probably already figure out we're going to use this theorem, ASA, the angle side angle theorem, to prove triangles are congruent. All right, here's our objectives or our learning targets as we sort of go through this set of videos. You'll need to be able to decide whether the triangles are congruent. You'll prove that triangles are congruent. We are going to do a few proofs. And then we'll go ahead and use this angle side angle congruence theorem to absolutely find the measure, the missing measures of either sides or angles of congruent triangles. Again, I also teach algebra, and so any chance I get to do algebra with you, we're going to do some algebra, and this is really where we're going to see some of that algebra come in. All right, let's just jump right into this and show you what is the angle side angle triangle congruence theorem. Well, here it is right here in a nutshell. It simply says this. If two angles, and the really important, guys, this is really important. We're going to talk about, we're going to spend just a teeny bit of time, we're going to spend some time here talking about this. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle. That's only 3 things, guys. If you can prove that two angles, an angle and another angle, and the included side, the side between those two angles, so 3 things, 2 angles and one side, if you can prove those 3 things, then the triangles are congruent. Now that is a lot better than what we were doing in the previous section. Remember, CPCTC required you to prove that all 3 pairs of corresponding sides and all 3 pairs of corresponding angles were congruent. That's 6 things you had to prove congruent. This theorem is cutting that in half. This theorem is saying you actually only need to show that 2 corresponding angles and the included side are congruent. If you can prove those 3 things, the theorem says the triangles must be congruent. And let me show you why here in this diagram. Here's the idea. If I have 2 angles that are congruent, and let's say it's these 2 angles, A and B, all right? So I have an angle of 30 and an angle of 40, all right? Those 2 angles are the same, right? Congruent to 2 angles in another triangle. So this one is 30, and this one over here is 40. Now, let's think about this for a second. Please notice what happens, all right? As long as these angles, right, these angles are the same, why does it have to be the included side? Watch this. Think about, imagine with me, use your imagination here. Picture what would happen if I began to change the size of this included side, the side between the angles, right? Angle 30, angle 40, the included side is the side between those two angles. What would happen if I began to change, right, the length of this side? Well, what would happen is, if I can for a second here, let's say that I made it a little bit shorter, right? Then this angle here would just get shifted in here. And this guy over here would just get shifted in a little bit. Right? And what it would do, right, is I make this included side shorter. Do you see what happened? What happened to the lengths of the other two sides? Yeah, they also got shorter. Please recognize that by changing the length of the included side, it will determine the length of the other two sides. Let's try. What if I made that included side a little bit longer? What if I made it a little bit longer? Again, I keep right. This has to stay a 30-degree angle. This has to, I'm not changing the angle. I'm simply changing the length of the included side. Well, if I did that, now that angle comes out to here. And this angle comes out to here. Let me go ahead and erase those ones in there so we're not getting confused by all these lines running around. Right? What happened? What do you see? Well, if I go ahead and make that included angle, I go ahead and make that included side bigger, what has happened to the other two sides? Please notice that they have also got, here's why it must be two angles and the included side. The reason it must be the included side is because that side between the two angles will determine the length of the other two sides. So what this means is if you can show that that included side is the same in both triangles, if I can show, let me erase all this extra stuff out here. If I can show that this included side is the same, since that included side determines the length of the other two sides, then what I know without even having to check them, I don't even have to check. If I can show that that included side is congruent, then I know the other two sides must be congruent. They have to be, because it's this included side, by making it longer or shorter, that determines the length of the other two sides, all right? So that's why it's the angle, side, angle, right? It's got to be two angles and the included side. That included side, depending on its length, will determine the length of the other two sides. As long as that included side is congruent, you know the other two corresponding pairs of sides, they have to be congruent as well. They have to be, because their length is determined by that included side. All right, so let's just jump right into this. I got a few examples for us here. Here we go. All right, here's what I want you to do. I want you to determine whether the triangles are congruent. Let's figure out if they're congruent, and I'll need to be able to explain my reasoning. All right, here we go. Well, I need to show that these two triangles are congruent, and I want to prove as little as possible. Remember, CP, CTC require me to show or prove 6 things. That is a lot of work. So, if I can do less work, I'll be happy. All right. Well, here's what I know. Look at this. I have an angle, angle A, an included side, and angle C. So if I can show, right, that angle A and angle D are congruent. If I can show that angle A and angle D are congruent, and I already know that this side right here is congruent to this side right here. I can see that it's given to me in the diagram. And I already know that this angle right here is congruent to this angle right here, right? So as long as all I have to do is show that angle A and angle D are congruent. If I can do that, then I have angle, side, angle. And I've proven by the ASA triangle theorem, these two triangles are congruent. So let's see if we can do that. Can I show that angle D is congruent to angle A? Well, any ideas? Well, I take a look at this and here's what I see. I remember from the previous section, right? In the previous set of notes, we learned that triangle sum theorem. Remember what the triangle sum theorem said? The triangle sum theorem said that all three interior angles must sum to 180 degrees. Well, I know two of the angles. Let's find that third one. So here's what I know. I know that 61 degrees plus 74 degrees plus, I don't know, angle D must equal 180 degrees. All right, well, here we go. 74 plus 61 should be 135, so 135 degrees plus angle D is equal to 180. Let's solve for angle D. Angle D is going to be equal to, I got to subtract the 135 to the other side. So 180 minus 135. Angle D is equal to 180 minus 135. Again, if you need a calculator to do that, please feel free to do so. But I get 45 degrees. Now, did that work? Angle D is 45 degrees. Boom, got it. Angle A and angle D are congruent. So here's what I know. I know that angle A is congruent to angle D. I just proved it using this triangle sum theorem. Angle D is 45, and I told you angle A was 45. So corresponding angles, awesome, right? Next, corresponding sides. I know that side AC is congruent to side DF. So I have an angle. I have an included side, and look, angle C and angle F are congruent. That looks like two C's. Let me fix that, make it look more like an angle. Angle C and angle F are congruent, and so, therefore, guys, by the ASA, angle side angle congruency theorem, triangle ABC is congruent to triangle DEF. And again, this is awesome, right? Because now I have a shortcut. All I had to do was show, right? Prove that two angles and the included side was congruent, right? As opposed to CPCTC, which required me to prove 6 things. Now all I have to do is prove 3 things. And if I can show that those 3 things are congruent, 2 angles and the included side, this theorem says those triangles must be congruent. Let's try another one. All right, let's see what we've got here. I think I see it. Do you see it? Look at this. Side JL. Side PM, look, 62 inches, 62 inches, corresponding sides, and they're congruent. Also, look, angle J and angle M, congruent. So here's what I need to do. In fact, let me put that in there, angle J, and angle M. So here's what I need to do. All I need to do is show. If I can show that angle L and angle P are congruent, then I have angle, side, angle, right? And I can use that theorem to show that these triangles are congruent. Okay, well, let's do it. Once again, guys, it's looking like it's that triangle sum theorem, right? I have 38 and 31, right? right? I need all three interior angles to sum to 180. So let's go ahead and do it again. I have 38 plus 31 plus angle P. It's got to sum to 180. The triangle sum theorem tells me all three interior angles must sum to 180 degrees. All right, let's see what happens. 38 plus 31 should be 69, so I get 69 degrees. Subtract that 69 to the other side. What do I get? Oh no. Oh no. I get 111, right? Use a calculator if you need to. 180 minus 69, 111. Here's what that means. Angle L and angle P are not congruent, right? So here's what I've got. I've got angle J is congruent to angle P. I have side JL is congruent to side MP. But right here, what I see is that angle P is not congruent to angle L. And remember, our contrapositive of CPCTC said if you can show that one pair of sides or one pair of angles are not congruent, then the triangles are not congruent. And right there, I've just shown you angle L and angle P are not congruent. Angle L is 110, angle P is 111. That is no bueno. Since those guys are not congruent, I know that these triangles are not congruent. Triangles are not congruent. Okay, awesome. Hey, I got another one here for you guys. Let's see what we get with this next one. Maybe we'll get lucky. Here's what we got. Determine whether the triangles are congruent and explain your reasoning. Well, I don't know. What can you see? Here's what I see. I see that I have corresponding angles B and C, right? If I take this triangle and flip it over, right? Angle B and angle C are corresponding angles. They're angles that would lie on top of each other. And I'm showing in the diagram that they're congruent. So I know angle B is congruent to angle C. Angle B is congruent to angle C. What else do I know? Well, look at the diagram, right? What do those little hashes tell me? Those little hash marks tell me that the segment BD is congruent to the segment DC or CD, whichever way you want to say it, doesn't matter. They're congruent. So I know that BD, that segment, is congruent to segment CD. Awesome, so far I'm off to a great start. I got an angle, I have an included side. All I have to now show is that, right, angle D is congruent to angle D. Well, guys, actually this is really simple, right? It's the linear pair theorem. Oh, actually, sorry, here, let me do it in a different color. Right? What did the linear pair theorem say? Well, the linear pair theorem said that two angles must sum to 180 degrees. Must sum to 180 degrees. Well, that's what I've got, right? I have a linear pair. These two angles, right, form a linear pair. Angle BDA, right, plus angle CDA. So BDA. BDA and CDA, right? They form a linear pair. They're equal to 180 degrees. But I know angle CDA, it tells me in the diagram, it's 90. So plug that in. Angle BDA plus 90 degrees is equal to 180. Well, this is an easy one to solve. Subtract the 90 degrees to the other side, and we get angle BDA must also be 90 degrees. But I doubt you guys even need to do the math to see that. If this guy's 90, this guy has to be 90. It has to be 90. That's the only way it sums to 180 degrees. So anyway, we've shown it, right? The linear pair theorem, they got to sum to 180 degrees, and there they are, right? So I've got 90 and 90 sums to 180 degrees. But more importantly, what that tells me, right there, that angle BDA is congruent to angle CDA. And by showing that an angle, the included side, and another angle are all congruent, what have I done? Well, sure enough, angle, side, angle, congruence theorem. Congruence, I think there was an E on the end. Sorry, I apologize for that. I spelled congruence wrong. Angle, side, angle, congruence theorem proves these triangles are congruent. And this is great for us. Again, remember, in the previous section, CP, we had to show 6 things. I had to show that 3 corresponding sides and 3 corresponding pairs of angles were congruent. Now, I only have to prove 3 things, right? Half the work to still show that triangles are congruent, which is awesome. Head on over to the next page of the notes. We'll take a look at a few more of these problems together and actually do a few proofs. I'll meet you guys there.